All right, here we are with question number 4, and it says cobalt metal is oxidized to cobalt plus 2 by the nitrate ion in the presence of a strong acid. Nitric oxide is one of the products. Answer the following. The table of circ charts may be helpful, so you'll have this on the test. Cathode half reaction then would be the reduction one. Reduction half reaction. And the anode half reaction would be the oxidation half reaction. And it tells me that cobalt is oxidized from cobalt to cobalt plus 2. So that's my oxidation half reaction. And then it says it's oxidized by the nitrate ion. So that means the nitrate ion is going to be the reduction half reaction. And that one says it's going to make some NO gas. And it happens to be in the presence of a strong acid, so that means there's going to be H pluses in there. But those are going to show up as I go through the steps of writing the balanced redox reaction. So the first step in balancing half reactions, once you've got them set up like this, is to balance everything except for hydrogen and oxygen. Nitrogens are done, cobalts are done. Second, you have to go through and balance oxygens by adding waters. And since there's 3 oxygens here and 1 here, I'd add 2 H2Os right here. That gives me 2 more oxygens plus 1 is 3. Next, balance hydrogens by adding H plus because it's in the presence of a strong acid. And since there's 4 hydrogens here, I'd write 4 H plus right here. And now that I have everything balanced for mass, hydrogens, oxygens, and nitrogens, now I would need to write the number of electrons that would need to make the reactions balanced. So I have a 0 charge over here on this side. I have a positive 4 plus negative 1 right here, so positive 3 reaction there. So we'd need 3 electrons right here to make that side balanced. And then in this half reaction, the only thing there is cobalt, but this cobalt is plus 2. I'd need 2 electrons to make it 0 on this side and 0 on this side. Okay, now lastly I'd ask for the overall balanced reaction, and to do that I'm going to have to make the electrons equal to one another. And so since there's 3 here and 2 here, I'm going to multiply this reaction by 2 to give me 6 electrons, and I'm going to multiply this reaction by 3 to give me 6 electrons. So I'm going to rewrite these right down here, and here is my cathode half reaction again, multiplied by 2, so that would be 6 electrons plus 8 H pluses, 2 times 4, plus 2 NO3 minuses, arrow, 2 NOs, plus 2 times 2 is 4 H2Os. And then my anode half reaction, my oxidation half reaction, would then be 3 cobalts goes to 3 cobalt plus 2s plus 3 times 2 or 6 electrons. Now to make the overall reaction, I'd take everything on this side and combine it, and I'd take everything on this side and combine it and cancel out anything that's the same. So the 6 electrons would end up going away because they're the same on both sides. And it looks like everything else is unique. So my overall balanced reaction would be 8H plus 2 NO3 minus plus 3 COs. Make sure that's a small o because that's cobalt. 2 NO plus 4 H2O plus 3 CO positive 2. And then you could check it. 8 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens, 2 plus 4 is 6 oxygens, 3 cobalts, 3 cobalts. Check it for charge, plus 8, negative 2, so that's posi 6 here. And here it's 3 times 2, that's posi 6, and those are all zeros as well. So there's your balanced redox reaction.